Alright, this is a review for exam 2 on the derivative. As you can tell, I'm probably going to lose my voice, but we will go as far as we can go here. So, this exam we did we did part 0 in class, so we want to pick up here with number 1. So we're going to let the function here be 1 over 4x. And what we want to do is use the definition of the derivative to find f prime of x. So let's do this right down here. Let's write down the definition of the derivative. So part A, we want to find f prime of x, which is equal to the limit as h goes to 0 of f of x plus h minus f of x all divided by h. And then let's do what it says. So the idea is wherever I see an x plus h, wherever I see an x, right here, I'm going to plug in this x plus h. And so what do I have? I have the limit as h goes to 0 of 1 over 4, and where I see that yellow x, I'm going to put x plus h, so all times x plus h minus f of x, which is 1 over 4x, and then all divided by h. And then the idea is I need to get a common denominator. So I realize that I have an x over here, but I don't have an x over here, so I can put an x. Let's put it right there. And if I put it in top, I better put it, if I put it in bottom, I better put it in top. And over here, I'm going to need an x plus h. And so if I put it in bottom, I better put it in top, so I'll put an x plus h on top. And so now that I have a common denominator, I can rewrite this as being equal to the limit as h goes to 0 of x minus the quantity x plus h, all divided by my common denominator, 4x, x plus h, and then all divided by h. And so this is equal to then the limit as h goes to 0. And you'll notice here I'm going to get cancellation x minus x, and then I'll have minus a plus, so I'll minus h on top, all divided by 4x, x plus h, and this is then all divided by h. And remember, when you divide by h, it's really h over 1, so when you divide by a fraction, it's the same as multiplying by the reciprocal. So I can then rewrite this as being equal to the limit. Notice the limit's still there. I have not evaluated the limit, so I do not drop it off. And I have minus h over 4x, x plus h, all times the reciprocal of h over 1, so 1 over h. And here's where the h's cancel. And so this is equal to the limit as h goes to 0 of negative 1, because there's a minus sign right here, all divided by 4x times x plus h in the bottom. And now I can drop off the limit because I'm going to evaluate it, which means in this case plug in h equals 0, so I get minus 1 over 4x all times x plus 0, which is just equal to minus 1 over 4. X times x is an x squared. And so that's my answer. There's the first derivative. The next thing I want to do is I want to find the second derivative. And so to find the second derivative, this is supposed to say part B, although it says A again, but part B, f double prime of x, it's basically the same thing. The only difference, I have this limit of h goes to 0, so the only difference is this, instead of f, it's f prime of x plus h minus f prime of x all divided by h. And so this is equal to the limit as h goes to 0. And I'm going to do the same thing I did before. So let's use green here. Wherever I see an x, so here's my x, I'm going to plug in an x plus h. And so for this one, I have minus 1 over 4 times the quantity x plus h squared minus, now f prime of x is just this, what we found before. So that's just minus 1 over 4x squared, all divided by h. All right, now I need to find a common denominator. So just like I did before, I notice there's an x squared over here, so I'm going to put an x squared right in between there. So if I do it on bottom, I better do it on top so I don't change it. And then over here, I'm going to need an x plus h quantity squared. And so let's extend this vinculum and then put an x plus h quantity squared up there. And notice a plus and a plus is going to make a minus, and a minus is going to make a plus. So that's going to be a plus sign. And then so this is equal to the limit as h goes to 0 of minus x squared plus an x plus h squared. So that's x squared plus 2xh plus h squared, all divided by this common denominator, 4x squared times x plus h quantity squared. And then that's all divided by h. And so that's equal to cancel, cancel. And so I have the limit as h goes to 0 of 2xh plus h squared divided by 4x squared x plus h quantity squared, all divided by h. Now at this point, if you tried to plug in h equals 0, you'll see you're going to get this indeterminate form 0 over 0 because h will be 0 here and here, so that'll be 0, and then the bottom will be 0. So there's more algebra for us to do. And so this is equal to the limit as h goes to 0. And what you want to realize is that you can factor out an h. So if you look here, this has an h and this has an h. You can factor out. And then that bottom is really h over 1, so you can multiply by the reciprocal. So on top I have factor out the h, so I have 2x plus h squared, all divided by that common denominator, 4x squared, and then the quantity x plus h squared, and then times a 1 over h. Here's where the h's will cancel, one on top, one on bottom. And notice I still have the limit, so equals the limit as h goes to 0. You can't drop that off until you plug in h equals 0. And so I have 2x plus h squared on top, all divided by 4x squared times the quantity x plus h squared. And now I'm going to plug in h equals 0. So I drop off the limit, so it's gone. So 2x plus 0 squared divided by 4x, the quantity x plus 0 squared. And then that's equal to a 2x on top. And then I have a 4x times x squared on the bottom. And so 2's are going to cancel and an x is going to cancel. So I'm going to have 1 over 2 x cubed. And so there's my second derivative using the definition. All right, now part C. For part C, what we want to do is we want to find the equation of the tangent line at x equal 5. So find the equation of the tangent line at x equal to 5. All right, so what do we have? We know our function, our f of x, is equal to 1 over 4x. We found our derivative, and I'll write this down because we're going to need it later, is minus 1 over 4x squared. And we want to find the equation of the tangent line at x equal to 5. So now I could graph this, and if you graph it with your graphing calculator, you'll see that it looks something like this. And so at 5, there's the point 5, I can plug in 5. And this is, remember, my function f of x. So when you plug in 5, I get out 1 over 20. So I have the point. And I want to find the equation of my tangent line. And so I can draw a tangent line here So here's my tangent line, and I have point, but I need slope. Right? Slope is rate of change. I say rate of change. You say find the derivative, and I'm going to find the derivative and plug in the input, which is 5. And I already found the derivative, so I can do that. That's minus 1 over 4 times 5 squared. And so that's negative 1 over 100. So I have my slope, I have my point, and so I can go ahead and plug in to my slope point form here. So I'll plug into my y minus y1 equal to m times x minus x1. And so I have y minus, y minus, and then my y1 is that 1 over 20, equal to negative 100. 1 over 100 is my slope, all times x minus 5. And now all I want to do is solve this then for y. And so let's do that. And so I have y minus 1 over 20 equals a negative 1 over 100 times x plus a 5 over 100. And so y is equal to minus 1 over 100 x plus, what's this, 1 over 20. And then to move over the minus, I'll add it. So 1 over 20. And so y is equal to minus 1 over 100 times x plus 1 over 20 plus 1 over 20 is 2 over 20, which is 1/10. So plus 1/10. And that's my answer. Now I can check this. I see the slope is negative 1 over 100. And if I plug in 5, I get negative 5 over 100, which is negative 1 over 20. And if you add that to 1 over 20, you get out positive 1 over 20. So it checks. And so that's the right answer. All right, the next problem has to do with interpreting the derivative, how the derivative measures change. And so if you read here, it says the temperature T in degrees Celsius of a hot cup of coffee just poured from the coffee pot is given by capital T, which is equal to the function f of t, where t is in minutes, since the coffee was poured. And we want to answer these following questions. So first, understand what the graph of this would look like. So in class, I tried to give you a hint. So here's time and here's temp. When you pour a cup of coffee, it's hot, so it's up here. After a while, it cools towards room temperature, which let's put like right around here. So let's draw a dotted line at room temperature. And the idea is it's going to cool. It's going to cool quickly at first, and then it's going to start to kind of level out. So it's going to do something kind of like that. All right, so this is really my capital T equal to f of t. And so what are the units? So let's go through this, part A. What are the units of f prime of 10? So let's just think. Okay, I say derivative, you say rate of change. So f prime is really this d capital T, d little t. That's what it really is, and that's equal to, well, on top you have degrees Celsius, and then on bottom you have time, which is in minutes, and that makes sense. The derivative f prime of 10 is in degrees Celsius per minute. It's telling you how the coffee is cooling in some sense after 10 minutes at that instant. Part B is f prime of t positive or negative, and why? Well, hopefully you see that f is decreasing, so that means f prime of t has to be negative. And the reason it's negative is because the coffee is doing what? It's cooling towards room temperature. Right? So it's cooling towards room temperature. So of course the rate of change, the derivative, is going to be negative. All right, let's look at part C that asks about double prime. So part C, what are the units of f double prime? Now remember, f double prime is found by taking the derivative. If you want, you can even write this, df prime dt. which says take the derivative of f prime, derivative of the derivative, and you know the derivative, we already talked about it, its units are degrees Celsius per minute, and then dt, of course, is in minutes, so it's degrees Celsius per minute. It tells you how the rate of change is changing each minute. You could also write this as degrees Celsius per minute squared if you want. It means the same thing. And then finally, part D is f double prime positive or negative. Well, from the picture, you can see it's concave what? It's concave up. It's part of a smile. So we know if it's concave up, we know f double prime has to be positive. But why is it positive? Well, as the coffee cools, the rate of change at which the coffee cools actually increases. Now, that might be somewhat counterintuitive, but you have to look and see what's going on here. The rates of change, they're really steep here, but they're negative because they're going down. So this might be like, let's just say negative, I'm making numbers up, okay? Maybe negative 10 degrees Celsius per minute. And as you go down here, this might be like minus 1 degrees Celsius per minute. So the rates of change are increasing because it's going from a really big negative number to a smaller negative number, right? Negative 10 and negative 1. So the rates of change are actually increasing. So down here I'd say the rate at which let's do it like this. You have to be careful when you say something like this. So let's say that the rate of change of the temperature of the coffee is increasing. We're pretty safe with that statement in calculus. So I'd probably write something like that. You know, you could also say the rate of change of the coffee, or the derivative is increasing. That's, I think, even a better way. So another way to say this is that the derivative is increasing. So why is f double prime of t negative? Because the derivative. Why is f double prime of t positive? Because the derivative is increasing. So those are all both, good explanations, I think. All right, so number 3, this was actually from your quiz. And so this goes along with the saying that I gave you guys. And let's write this down. Positive ideas. So positive ideas go with what? Go with positive quantities. And then negative ideas go with negative quantities. And so when I think of derivatives, and when the first derivative is positive, it goes with the positive idea of up, right? So when the first derivative is positive, it goes the positive idea up. When the second derivative is positive, it goes the positive idea of smile, concave up. When the first derivative is negative, it goes with the negative idea of decreasing. When the second derivative is negative, it goes with the negative idea of concave down, right? CD. Right? So concave up, concave down. It looks like a frown. And so over here, when I'm doing these things, if I want to find f prime of 5, over here is 5. And so I look up here, and f prime is whether it's increasing or decreasing. I see it's decreasing, so it must be negative. F of negative 3, here's negative 3 right here. And then f of negative 3 is this height, and that height is negative. F double prime is 0. Well, here's 0. And then on the graph, it's part of a smile, so it's concave up, so it's positive. Right? Positive idea, concave up, positive quantity. F double prime of 3, well, here's 3. I look up on the graph. Now this is concavity. It's part of a frown, so it's concave down. So it goes with a negative. Negative idea, negative quantity. F prime of minus 1, well, here's minus 1. Then up here is on the graph, and I see f prime, because when you're ready to change it, it's going down, so it's also negative. F prime of 2, well, here's 2. If you look up, right, f prime of 2 tells me the rate of change is positive here, so it's increasing. So again, derivative's positive. F prime of 3, same idea. You come up here, here's 3. You come up here and you see, oh yeah, okay, rate of change is positive, so that's positive. F double prime of minus 2, so I'm right here. Here's minus 2, so I look up, and it's part of a frown, so it's concave down, so it's negative. F double prime of 5, here was 5, you look up here, it's part of a frown, so it's concave down, so it's also negative. And then f prime of 0, that's a little bit of a tricky one. Here there's no rate of change, it's either increasing or decreasing, so the derivative is 0. Moving on to number 4. And so in number 4, we're going to use the rules abstractly here. And so we're given this information here, and we want to find h prime of 3. And so in part A, I'm given h of x is this thing. And so to find h prime of x, I'll find that before I find h prime of 3, I realize that first I'm going to have to take the derivative of this thing and subtract off the derivative of that thing. And so the first thing's a little bit tough because I'm using a product rule, so I have a first function, which is an x, and a second function, which is my f of x. And so I simply say the rule, the derivative of the first, derivative of x is 1 times the second, plus the first times the derivative of the second, so times f prime of x. And then minus the derivative of g of x, which I just write g prime of x. And then I just plug in 3. So h prime of 3, wherever I see an x, I put a 3. So I have f of 3 plus 3 times f prime of 3 minus g prime of 3. And then I have to find these numbers. So f of 3 is 7 plus 3 times f prime of 3. F prime of 3 is 5 minus g prime of 3. G prime of 3 is 2. And so this is equal to 7 plus 15 minus 2, which equals 20. So that's my answer for part A. Part B, we do in a similar way. So here's part B. Here's my h of x up here. So to find h prime of x, this first part, this is really a chain rule. So let's highlight the inside and outside. So g of x is my inside, where my outside is the function f. And then I'll say the rule so I can find the derivative of the outside times derivative of the inside. So f prime of g of x times the derivative of the inside, which is g prime of x, minus the derivative of x squared, which is 2x. Now all I have to do is plug in 3, so h prime of 3 is equal to f prime of g of 3 times, and wherever I see an x I put a 3, g prime of 3 minus 2 times 3. And so that's equal to, and let's change colors here so it becomes clear, I need to find g of 3. So here's g of 3 is just the number 3. So that's equal to f prime of 3 times g prime of 3 is the number 2. So times 2 minus 6, which is equal to f prime of 3. F prime of 3 is 5. And so this is 5 times 2 minus 6, which equals the nice number of 4. And so that's my answer for part B. Alright, so now it's time to get crazy with derivatives. So we have a ton of derivatives to take here. And I'm going to try to finish this before my haircut, which is at 3:30. So I got about 15 minutes to do this. And okay, so let's get her done, right? Let's start here with number 5, right, part A. And we'll just copy them down as we go. Let's switch back to black. And so I have f of x equal to 5x to the 7th minus 3 over x squared plus 9. Now before I can take this derivative, I need to write this as a power of x. So I'm going to write this as 5x to the 7th minus 3x to the negative 2 plus 9. So I just rewrote it in a form that I can take the derivative of. And so then I take its derivative, f prime of x. These are just nice power rules. So the 7 comes down. So we have 5 times 7, which is 35, x to the 6. Now my negative 2 comes down, and negative 2 times minus 3 is a positive 6. X to the minus 2 minus 1, so minus 3 or negative 3. And then plus 0. And so this is equal to 35 x to the 6 plus 6 divided by x cubed. So that's the answer for the first one. Part B is a little bit harder. So let's copy down part B. Part B, I have g of x equal to the square root of x plus 2 divided by x minus 7. Now before I can take its derivative, I need to write this as a power, x plus 2 divided by x minus 7, because I can only differentiate a handful of things, right? Powers, constants, exponentials, logarithms, and trig functions. Right, so e's and ln's, trig functions. And so I'll write this all raised to the 1/2. And then when I look at this, hopefully you see there's going to be a quotient rule, but it's not the first rule you apply, because a quotient rule only applies to this inside part. It's actually a chain rule you're going to apply first, because there's an inside and an outside, and that rule will involve everything. And so I'll apply the chain rule, identify inside and outside, and then I say, okay, g prime of x is equal to the derivative of the outside, the 1/2 comes down, x plus 2 divided by x minus 7 to the negative 1/2 times the derivative of the inside. Now the derivative of the inside is a quotient rule, so I have my low function, which is x minus 7. The high, that's just 1, derivative of x is 1 plus 0, minus my high function, x plus 2, times the derivative of my low function, which again is just 1, because the derivative of x minus 7 is 1 minus 0, all over my low squared, so x minus 7 quantity squared. Now I can clean up the top. I have x minus 7, and then minus an x, minus a 2, because this times 1 is just this. And then x's will cancel, and I'll be left with minus 9 on top. So this is equal to 1/2, and let's just flip these, because that's what the negative sign says. So x minus 7 on top, x plus 2 on bottom. So I just flipped it, because that's what that negative sign means right there. And then all times minus 9 divided by x minus 7 quantity squared. And then I'm going to get some cancellation on top and bottom here. So if you see this, great. If not, think about it. I really have x minus 7 to the 1/2 and x minus 7 squared on the bottom. So what's going to happen here is I'm going to be left with a 9 on top, a 2 on bottom, and they'll have a square root of x plus 2. So that's x plus 2 to the 1/2. And then I'm going to have this x minus 7 no longer squared, because like 1/2 of them is going to cancel with, some of this down here. So I'm going to get it to the 3/2. And so this is really equal to, if you want to write it out, since they gave it to me in radical form, I should write everything back in radical form. So this is really equal to minus 9 divided by 2. I can pull out one of those x minus 7s, because this is really the square root of x minus 7 squared, and then all times the square root of x plus, let's write x plus 2, and also under the square root sign we have an x minus 7. So I'd probably write it like this. Right, remember this x minus 7 to the 3 halves. It really means what? Right, it means the square root of x minus 7 cubed. And so because it's cubed, you can pull out one of them, one of the x minus 7s, because the square root of anything squared is what's inside there. So you can pull out one of these, get x minus 7, times the square root of x minus 7. And then that square root of x minus 7 can combine with the square root of x plus 2 to get the square root of x plus 2 times the square root of x minus 7. All right, moving on. Part C. So part C, I have g of x equal to e to the 2x divided by 1 minus cosine x. So this is obviously a quotient rule. You have a high, you have a low, and it's low d high minus high d low, all over low squared, and away we go. So g prime of x is equal to, my low is 1 minus cosine of x, and then d high, here you have to be a little bit careful. This is a chain rule. You have inside, outside, and so derivative of the outside is e to the 2x, times the derivative of the inside, which is a 2, derivative of 2x is 2, minus the high, which is e to the 2x, times the derivative of low. So the derivative of low is 0, minus the derivative of cosine is negative sine, so you're going to get a positive sine x. Let's watch that again, okay? Derivative of 1 is 0, minus derivative of cosine is negative sine, so minus a negative is a positive sine x, all divided by the low squared, 1 minus cosine of x, quantity squared. Now you can pull out what they have in common. So take a look. They have an e to the 2x in common, so I'm going to pull that out. So this is going to be equal to e to the 2x all times, you have a 2 times 1 minus cosine of x minus a sine x, all divided by 1 minus cosine of x, quantity squared. Now you can leave it like this. I guess maybe I would just write this as e to the 2x all times 2, just multiply through by that 2 cosine of x minus sine x. And then, of course, all divided by that low squared, so 1 minus cosine of x, quantity squared. So I guess that would probably be my final answer. All right, part D. So on part D, I have h of x equal to 2x minus 1 to the 8th times x plus 5 to the 4th. And so hopefully you see this one. This is how to do this one. This is a product rule. And let's circle the first and put a square around the second. And then I can say this to myself and do it. So the derivative, h prime of x, would equal the derivative of the first, which is an 8, 2x minus 1 to the 7th, so that's derivative of the outside, times derivative of the inside, which is a 2, derivative of 2x minus 1 is just 2, minus 0, times the second, so x plus 5 to the 4th, plus the first, times the derivative of the second, so the 4 comes down, x plus 5, cubed, times the derivative of the inside, which is a 1. And so now I need to clean this up a bit. So I have 8 times 2, which is 16. So that's equal to 16. 2x minus 1 to the 7th. X plus 5 to the 4th. And then plus a 4. 2x minus 1 to the 8. And x plus 5 quantity cubed. And now I want to pull out what they have in common. So they have a 4 in common. They have a 2x minus 1, and you always pull out the lowest power, so it's to the 7th. And they also have an x plus 5 in common, and now what's the lowest power here? You have a 4 and a 3, so that's a 3. And you play this game, what goes here plus what goes there. And so in the first one, let's use 2 different colors. So, what goes here times this gives me that. And so hopefully you see you need a 4. You do not need a 2x minus 1 to the 7th because you got it here, but you're going to need an x plus 5 because you want it to the 4th power, so you only have it cubed. And then for the next one, let's use blue. And so what goes here times this gives me that. You already have the 4, and so you're just going to need a 2x minus 1 because you have the 4s, they match up. The 2x minus 1 times 2x minus 1 will give you the 8th because 7 plus 1 is 8. And then you already have the x plus 5 to the 3. And so let's clean this up on the inside here. And so I have 4x plus 20 plus 2x minus 1. So I get 6x plus 19. And so this is going to equal 4 times 2x minus 1 to the 7th times x plus 5 cubed. And then all times 6x plus 19. And that's my final answer. Okay, what's next? That was part D. Now we move on to part E. F of x is equal to x squared ln of x. So take a minute, look at it, think about it, and if you said it, x squared times ln of x, it'll tell you what to do. So it's a product rule. And here's my first. Here's my second. And once I identify which is which, I can say f prime of x is equal to derivative of the first, which is 2x, times the second, which is ln of x, plus the first, which is x squared, times the derivative of the second, which is 1 over x. And so this is going to equal 2x ln of x. And one of these x's is going to cancel with that x, and so just plus an x. And then I'll factor out what they have in common. So I have an x, and here I'll put 2 ln of x plus a 1. And so that's my final answer for that one. So that wasn't too bad. And then part F, so A, B, C, D, E, F. We need to go to a new page. So part F, let's go back here and add a page. So part F is g of x equal to, and we finally get into some inverse trigonometric functions. So we have tan inverse of x, all divided by x. And again, this is another quotient rule. I have a high and a low. So here's my high, here's my low. And to find g prime of x, I just say it. It's low d high, so x times derivative of the high, and the derivative of tan inverse is 1 over 1 plus x squared, minus the high, so tan inverse of x, times the derivative of the low, which is just 1. The low function is x, so the derivative is just 1. All over low squared, so all over x squared. So derivative is done. The rest is algebra. To clean this up, I would probably just multiply my top and bottom by 1 plus x squared. Oops. So multiply top and bottom by 1 plus x squared divided by 1 plus x squared. And the reason for this is you're multiplying by 1, so you're not changing the expression, but this will cancel with that. And so this will equal, so I have this times this, and so I'm just going to be left with x, minus, I have this times this, so I'm going to have 1 plus x squared, tan inverse of x, all divided by this times that, so I just have x squared times 1 plus x squared. and I'm all done. This is my answer. All right, and then the last one on this derivative section, and it's 3/12, so I still have time to go. The last one here, let's change back to black. So my last one, I have G. Oh, I thought I just did G. Oh, I did F. It was G of X. Okay, then G is F of X equal to X ln of sine inverse X. And this one's a tough one. As first you have to identify, and hopefully if you think about this, you say X times ln of sine inverse of X. So this is actually a product rule. There's the X. There's your first. And there's your second. And so F prime of X is equal to the derivative of the first, which is 1, times the second, so ln sine inverse of X, plus the first, which is X, times derivative of the second. Now the derivative of the second, you have to realize it has an inside and an outside, so derivative of ln is 1 over, so 1 over sine inverse of X, times the derivative of the inside, so derivative of sine inverse is 1 divided by the square root of 1 minus X squared. And so I'd probably just write this as equal to the ln of sine inverse of X plus X divided by, and then I have sine inverse of X on the bottom with the square root of 1 minus X squared. And that's my answer. I'm finishing with time to spare, so we will go on and do the very last problem here and complete this review. So number 6, find y prime. And so here's my explicit equation, and so I'll differentiate, not explicit, implicit equation. All right, so here's my implicit equation, so I'll differentiate implicitly. So I take the derivative of tan inverse of y, so that's derivative of tan inverse is 1 over 1 plus y squared times y prime minus a 6x equal to 0 minus, and now this is a product rule. Here's my first, there's my second. So minus the quantity, derivative of first is 1, times the second, so ln of y, plus my first, times the derivative ln of y is 1 over y prime. And so let's clean this up. I have 1 over 1 plus y squared, y prime, minus 6x, equal to negative ln of y, minus, because negative at plus is a minus, minus x over y prime. And now I'd probably, just to clean this all up, get rid of this y and get rid of this 1 plus y squared by multiplying both sides by y, 1 plus y squared. And if you do that, nice things will happen. So when I multiply this, by that, the 1 plus y squareds will cancel, so I'm going to get a y prime minus 6x times that, so times y, 1 plus y squared, minus ln times that thing. So I have equal to, negative, and let's put a y here, then 1 plus y squared, ln of y. And then here, I'll multiply this by that. Now y's will cancel, so I'll get minus x, 1 plus y squared, y prime. And then what I want to do is move all the y prime stuff over to one side. So I'm going to have y prime over here, and then plus x, 1 plus y squared, y prime. So I want to move that over, so I add it. And then I want to move this over to the right-hand side, so I'll add it too. So this is going to be equal to then 6xy, 1 plus y squared minus a y 1 plus y squared ln of y. And then I want to factor out a y prime because there's a y prime in common. So I'll factor out a y prime. And this is all times y plus x times 1 plus y squared equal to, and I can factor out a y times 1 plus y squared here actually, so I guess I didn't have to multiply through on the right hand side with that, but that's okay. So I have 6x minus an ln of y, and then I just divide by this. Y prime is equal to y times 1 plus y squared 6x minus ln of y, all divided by y plus x times 1 plus y squared. And that completes our review. And if you're curious, it is 3:18, and I am going to be late for my haircut. Good luck studying, guys. See you on Monday.